Hello and welcome back. Today's video is about getting started and we are going to learn the foundations, and in doing so we are programming the LEDs and also will be calculating the resistor values. The LED is used as an indicator on the actual robot, so when the bot is not moving you can see that the red LED is turned on and the blue LED, which is located here, stays off. And when the bot starts moving you can see that the red LED turns off and the blue LED turns on. So keeping that in mind, we are going to learn the basics. Now don't worry about the circuit here, we will be building it as the course progresses. Right now all you need is a breadboard, few components just to get started. For today's lesson we will need the ESP32 with the mini USB cable, two breadboards, three LEDs of different colors, jumper wires and resistors. The values for the resistors can be between 60 ohms and 220 ohms depending on the color of the LED. So if you have like a red, amber, yellow or orange LED, you can go ahead with 220 ohms or higher value. And if you have like a green, blue or white LED, then you can go with 60 ohms or higher. There's a lot to be covered, so let's begin. Feel free to skip directly to the programming basics section using the timestamps if you have already installed the Arduino IDE along with the necessary drivers. If not, then just follow along. I will first show you how to install the IDE on Windows and then show it on Mac. First up, let me start off with Windows. Installing the IDE on Windows is pretty straightforward. Firstly, open up a browser of your choice and point over the address bar and type in arduino.cc. Make sure you get the spelling right. Then click on Software and then click on the first download option where it says Windows 10 and newer. Then click on Just Download, followed by Just Download. For the purposes of this video, I have already downloaded the installer, so let me walk you through the installation process. Open your File Explorer and navigate to the Downloads folder and click on the Arduino installer. This should open up the installer. Click on I agree, next and install. This should take you a couple of minutes and I'll get back once it finishes installing. The IDE installed successfully. Keep the Run Arduino IDE option checked and say Finish. This should open the IDE, so let's wait for it to load. Let me fast forward this for you. And there you have it. You can now skip to the installing drivers section, as next up we have the installation on Mac. Let me now walk you through the installation of the IDE on a Mac. You would want to head over to arduino.cc, so let me open up my browser and type in arduino.cc, and you can then click on the software tab here on the top of the page. This should take you right to the downloads page, and based on the type of MacBook you have, you can either select Intel or Apple Silicon. So I'll go ahead with Apple Silicon, but if you have an older version of the MacBook, then you can click on Intel. You can just say just download and followed by just download, and this should start the download of your installer. So in order to save some time, I have already downloaded the installer. So let me just clear that out. So once your installer is downloaded, you can navigate to the downloads folder in your Finder and you can launch the installer. And all you got to do is just drag this to your applications folder, and this is pretty much how you install the IDE on a Mac. So let me open up the Arduino IDE and it should prompt you with a pop-up. Just say open and there you go. In this section of the tutorial, we'll be talking about installing necessary drivers and why do we need them in the first place. So let me open up my IDE and let me try connecting my ESP32 to my laptop over here. And before I do that, let me open up the port section. So keep your eye here. The second I connect my ESP32 to my laptop, you can see that there is a new listing here which says USB serial. This is how your computer or your laptop recognizes the ESP32. So if this doesn't show up, then you are missing necessary drivers, and you need to follow along where I'll show you how to install the drivers. But this is not the case with my Windows machine. So if I try connecting the same ESP32 to my Windows machine, you can see that it says no ports discovered. So the Windows machine was unable to recognize my device, although I could hear the pop-up sound when you connect the USB, but it is not able to recognize the device. Okay, now if you take a close look at the ESP32 you have, you can see that there is this small square chip. Okay, you have this depending on the ESP. Okay, it can also be this rectangular chip here, but more or less the one that is located here. Okay, so what this chip essentially does is it is responsible for the communication between your USB and your actual microcontroller. Okay, and this chip goes by the name USB to UART bridge. Okay, and it's literally a bridge between your USB and your microcontroller here, and it uses UART to communicate between the USB and the microcontroller. And if you flash some light on the chip and try reading the part number, you will see that 99% of the times it is CP2102. Okay, and if you have this longer version of the chip, then it's definitely CH340C, but very rarely you will find that it is CH9102. Okay, so depending on the chip you have, you need to install the drivers. So please check the description below. I have given Windows and Mac links for all of these drivers. Okay, on Linux you don't have this problem because it's kind of sorted out on Linux. You'll only have such problems on Windows or Mac. So let me go ahead and install it for the CP2102. So this is the installation page. It's pretty straightforward. You just have to do next, 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 and you'll be good to go. So I want to install the Mac OS drivers, right? So this is the one I need to click on, and yeah, it prevented me from a pop-up. So let me open up the folder and click the installer and say open. Okay, so all I got to do now is continue, continue, say agree, continue. It's asking me for my password. I think I typed in my wrong password. Okay, okay, fine. So there's another pop-up. You need to don't press OK. Press on Open System Settings, and therein you need to toggle this, and it's asking again for my password. So once you do that, the driver is successfully installed. So let me close all of this and eject this. Now when I go back, okay, and if I take a look at the port and let me connect my ESP32, you can see that strange, it's not showing up. Okay, let me try closing the IDE and reopening the IDE. So I think that should do it. Okay, I think I have some kind of a loose connection here with my wires, but as you can see now that it did, and it is under the name slab underscore USB to UART. So this is what you need to be seeing if you have installed the drivers. And similarly on Windows 2, you should be seeing something like that. So that is how you install the drivers. And next up, we will be starting programming With the board setup and the ESP32 detected, there is one last thing you need to, and that is adding the ESP32 from the boards manager. You want to head over to the boards manager, which is here, and type in ESP32. And you want to install the one which says ESP32 by Espressif Systems. So let me go ahead and click on install. Okay, so it has installed, and you can verify that by clicking here and selecting the select other board and port. So the drivers that you had installed earlier were required for the board to basically detect the port of the board. And now that you have installed the boards from the boards manager, you can easily try finding your board here. And okay, let me just scroll here and go to where it says ESP32, and you wanna it's already selected, so you wanna select the one which says ESP32 dev module, and let me click on OK. All right. Code is typically split into three sections. First, the global section. Anything written here can be accessed anywhere in your program, including your setup scope and your loop scope. What are scopes? Well, the ones defined using an opening bracket and a closing bracket is said to be a scope, and code written between these brackets is said to be inside a scope. So if I write something inside a scope, it can only be accessed locally here, but it cannot be accessed outside the scope. So for example, if I write something here in void setup, I cannot access it inside void loop. But if I write something here in the global scope, I can access it inside void setup as well as void loop. All right, so let's try turning the LED on now. So firstly, you want to configure the pin as an output device, right? And the way you do that is you use this API called as pin mode. So what pin mode essentially does is that it sets the pin for current to flow out of the pin. Okay, it doesn't start pushing the current out of the pin, it just sets it up. Now if you want to push the current out of the pin, you have to write digital. Okay, let me not do it there, let me just do it here. So digital write, you give the pin number and you say hi. Okay, so let me compile this code and upload the code. Before that, let me connect my ESP32 back again. So I can just directly say upload, because upload does both compile and upload, whereas compile it only compiles the code, right? So you can just use upload. Okay, that took quite some while, but you can see that the LED is turned on. Now what if you want to turn the LED off? You can just make this low. Okay, you can see that the LED is turned off now. How about we blink the LED now? So you want to turn the LED on, and then you want to turn the LED off, right? So you give the pin number and you say low, but you want to blink it for at least 1 second. So that is where another Arduino API comes into handy, and that is delay. And you need to specify the time in milliseconds. So 1000 milliseconds is 1 second. So you want to turn the LED on for a second, and then you want to turn it off. But you can see that the code inside void setup scope executes only once. So if I upload this code now, it should only blink once, but we don't want that. We want it to blink forever, right? So I can just copy this code. Let me just cut that out and paste it inside void loop. And let me hit on upload. As you can see, it's not acting quite the way we expected to. We were expecting it to blink, but as you can see, it is just turned on. So I've done this intentionally. So can you take a guess why exactly instead of blinking it is like it's just on? Okay, so let me help you analyze the code now. So we have turned the LED on for a second. Okay, we've turned it on. We are waiting for a second and we have turned it on, right? So isn't that what's happening? Turns out that's exactly what's happening, but there's a small catch. Okay, so it turns on and then it waits for a second. It turns off, but then immediately it turns back on again, right? So your eye is not able to see that because it's happening so fast, because the ESP32 has a clock cycle of somewhere around 240 megahertz or something like that. So it's happening so fast that your eyes cannot see the LED going off. Okay, and that is the reason why it is, when you look at it, it looks like it's turned on. So in order to fix it, we can add another delay here and we can specify another second. So let me try uploading the code now. All right, you can now see that the LED is turning on for a second and it's turning off for a second. Let's say you want to blink the LED for exactly 3 times in a row. So I want you to take this as a challenge and try doing this on your own. You would want to blink the LED for exactly 3 times and no more than that. Okay, so pause the video. All right, we are back. So let's try solving this. So you would want to replicate this code for 3 times, but then you soon realize that as it's inside the void loop, and when the control reaches here, it would go back again, and then it would blink for another 3 times, and again the control reaches in the top. And so basically this is looping indefinitely and blinking indefinitely, although the logic here is meant to be to blink it 3 times. So you would want to cut this out and paste it under void setup, because remember, void setup executes only once and then the control reaches to void loop, which keeps looping forever, right? Okay, so this solves the problem. Okay, let me try uploading the code to the ESP now. Okay, keep an eye on the LED. 1, 2, 3, and it stops blinking. Okay, great. Let me now start talking about macros. Whenever you want to define a pin number, you might have seen a statement like hash define LED pin followed by the pin number. And instead of hard coding the pin number throughout the code, let us find and replace all occurrences of the pin number with the macro name LED pin. But do you really know what happens when you say hash define LED pin 2? Well, in C or C++, hash define is used to define a macro, and macros is a feature similar to your text replacement mechanism. What it does is wherever you say LED pin, that will eventually be replaced with the number 2. And this happens during the compilation stage. So if you take a look at the compiled code, you would see something like this. And when does compilation happen? So when you hit the upload button, there are 2 steps. The first step is compilation and the second step is your upload or your flashing. So during that compilation stage, the compiler starts checking line by line. And the second it hits this statement where it says hash define LED pin, it knows that all occurrences of LED pin have to be replaced with 2. So you might be wondering, what if it is not 2 and it was some random string? Then it will replace all the occurrences with this random string verbatim. So macros are pretty dumb and they don't check for what value has been assigned to the macro name, and that makes it a little unsafe, but C++ has a better way to do it, and that's something we'll be taking a look at in the future videos. So for now, let me get back the 2 and try uploading the code, figure out if the code compiles and uploads successfully. As you can see, the code compiled and uploaded successfully. As I have started with programming, so I would like to continue with building the LED circuit for now. And let's take peripherals in the later part of this video. All right, let's start with the LED circuit. If you're already familiar with how to build an LED circuit, then I would urge you to skip to the programming section for the circuit. If not, then you can just follow along. When you look at an LED, you can see that there is a long leg and there is a short leg. The long leg is called as the anode and the short leg is called as the cathode. The anode connects to your positive 3.3 volts or your 5 volts, and the cathode connects to your ground. So for example, if I were to connect this LED to your ESP32, it would look something like this. I would connect the long leg to your VIN pin and your short leg to your ground pin. Now please note that you don't want to try this because the VIN pin is connected to your USB, so it will be having 5 volts and this will burn your LED. Hypothetically, if you do this connection, okay, the LED will pull as much current as it requires to burn as brightly as possible, and in doing so, it will shorten its lifespan and it will burn very brightly. To prevent the LED from burning out, what we could do is we could add a resistor between the VIN pin and the long leg of the LED. So it would look something like this. This is exactly what we will be building. We won't be hooking up the LED directly to the pins. Rather, we'll be using a breadboard to make the connections. You can see here that I have drawn the symbols rather than the actual image. So the resistor is denoted by the zigzag symbol and the LED is given by this particular symbol here. And you can see that the anode is on this side and the cathode is on the other side. Now, instead of connecting to the VIN pin, in this example, I have connected it to pin number 23. The reason being we want to blink the LED or we want to control the LED, so we can use the GPIO to do so. So let's go ahead and start building this circuit. So those of you who are clear about this circuit can go ahead and start building it on the breadboard. For those who don't know how to use a breadboard, stick around. I will discuss how to use a breadboard and then we can start building the actual circuit. If you take a look at the breadboard you have, you can see that there is a double-sided tape layer. And if you just peel it, don't do that because you won't be able to put it back. But this image here is the peeled image. So I have removed the double-sided tape and this is how it would look without the double-sided tape. Just by looking at this picture, I think you would have an idea on how to use the breadboard now. You can see that the rows are shorted and the columns are shorted throughout the board. Like what I mean by that is the column is shorted all the way from the first hole here all the way to the last hole. But it's not in the case of the rows. You can see that this row, which contains 5 holes, is shorted, but then there is a trench in the middle, right? And on the other side of the trench, again, the 5 holes are again shorted. So if you connect something on this side, it is not connected on the other side of the breadboard. So you would have to bridge this using some kind of a wire if you want to, connect the entire row. So for the purposes of this video, we'll be using 2 breadboards because the ESP32 just doesn't fit on one breadboard. So you can see that there are notches here on the sides. So we will take 2 breadboards and connect them through these notches. I'll be going over that shortly. Let me show you how the breadboard looks from the front. So this is how it looks from the front, and you know that the rows are all connected. Again, let me just rotate the breadboard to get a clearer understanding on how to use the LED with the breadboard now. If I were to give you a LED, how would you connect the LED on this breadboard? The 2 logical options would be, would you connect the LED like this or would you connect the LED like this? Think about it and please leave a comment in the comment section below. So if you say that you would connect the LED like this, then you are wrong, because if you give 5 volts here and if you ground the LED here, the current would not pass through the LED, and this is because current likes passing through the least resistant path. So imagine this current has to go through the long leg of the LED, go inside the LED, turn the LED on, and then flow out through the other leg of the LED and then flow to the ground. Or would current want to just just pass by without going through the actual LED. Which one do you think current would want to flow through? And the answer is it would want to go through the least resistant path, right? So this is not how you connect an LED. The right way of connecting an LED is like this. Okay, so let's say you connect 3.3 at this hole, current will flow through this hole all the way through the long leg of the LED inside the LED, and then it would flow out of the short leg and come out of this hole, and the circuit would be complete. This is the only possible path the current can take, and this is how we are going to hook up our LEDs. And if you ask me how would you connect the resistor, I would say the same way. You want to connect your LEDs and your resistors across the rows. Okay, they are looking like columns right now, but if you hold the breadboard vertically, then these would be the rows. So you want to connect the LEDs and your resistors across the rows. I have one last question for you, and after that we will start building the circuit. Now just take a look at these two diagrams here. In the first diagram, you can see that I have connected the resistor before the LED, and in the second diagram, you can see that I have connected the resistor after the LED. Now, which of these is the right way of hooking up an LED? Please leave a comment below in the comment section. Now, before I give you the answer, I want you to think intuitively and try analyzing the circuit by yourself. Let me start with the first one here. So let's say current starts flowing through the positive side of the battery and it goes through the resistor. And when it goes through the resistor, the flow of the current is slowed down. Okay. And then right after that, it would go through the LED. At this point, you can say that the LED is safe and it won't be burning brightly because the current has already been slowed down by the resistor, which is right before it. After it goes through the LED, it would want to go back to the ground. Let's try analyzing the second circuit here. So current would go through the battery and then it would go through the LED, and you might think that the LED is going to burn brightly here because you're directly connecting 5 volts or 3.3 volts right to the LED. All of the current is going to go through the LED first and then it's going to hit the resistor, but you are wrong. Okay, so current goes through the LED and it eventually gets slowed down when it hits the resistor. You want to think of this as in like a traffic stop. So when current slows down here, it doesn't slow down only here, it has to slow down all the way till the starting point of the battery. So you can say that the whole path here has been slowed down because of this resistor here. And then as usual, the other side of the resistor is connected to ground. So this completes the circuit. So if you had an option to pick between placing the resistor before the LED or placing the resistor after the LED, I would say pick any. My personal preference is the first one. I usually try connecting the resistor before the LED, but it's up to you. So let's now start building the actual circuit. Starting out, I want you to get your LED. I'm using blue LED here. For the resistor, you can use a 220 ohm resistor. As we have not yet learned how to calculate the value for the resistor, so you can go ahead with 220 ohms for now. Connect the LED across the rows like that and the resistor too, making sure that the long leg of LED is connected to one of the ends of the resistor. The resistor is a non-polar, so you can connect it either way. You then connect pin number 23 to the only end of the resistor and your other leg of the LED to the ground. This is how your circuit should look like. And once you're done with that, you can connect your ESP32 to your laptop. Let's program the ESP32 now. Select your board, and the only change you need to do in terms of the code is change your pin number from 2 to 23 and hit on upload. Here's your blink. Feel free to experiment with the circuit and try different things. For now, here's a challenge for you. Try blinking the LEDs alternatively with increasing delays. It should look something like this. I'll be posting the solution in the next video. Since this video is getting a bit long, I'll continue the remaining part in the next one. This video was intentionally paced slower to focus on the fundamentals. Starting with the next video, things will pick up speed. We'll tackle the buzzer and integrate it into the circuit. Remember, the concepts you're learning here are foundational, and mastering these basics will enable you to build almost anything from the first principles. All right, see you in the next one.